So after that first video, we'll be taking a look at an actual model and trying to recreate it in CAD. And so this was actually a practice problem that I was given in the Mr. Boone's engineering class last year. And so essentially, this is a very simple shape. It might not look like it, but essentially, this uses the constraints, the dimensioning, and the extrusion techniques that we learned in the first video, which I made. Maybe I'll stitch these two together, who knows? But essentially, I'm saying essentially a lot. Anyways, I'm using this drawing, which I sort of worked backwards on because I already sort of made this based on a worksheet. But I made it into a drawing and added the dimensions needed to CAD this out. Actually, there's missing one dimension right over here. There we go. Based on these dimensions right here, I'm hoping that you will be able to CAD this out. And it might be a little complicated at first, but here's what I'm going to do. I'm going to try to CAD this based on this drawing on the same document, but at different parts studio. So from this drawing, I'm going to use these dimensions here to try to make a model. So yeah, let's get started. So right here, down here, and the bar right here, there are a few options. Essentially, you're never going to really need a variable studio. You're sometimes use a folder for organizing, and you can import other files, external files that you want to work on in Onshape. But there are really three main things that you really need to know. Create a new part studio, create an assembly, and create a drawing. Drawing is essentially what you're seeing out here, is when you need to, this is more prevalent in, say, manufacturing parts or sending in prototypes, is you want everything dimensioned and nice and sort of laid out on a piece of paper for someone else to see. But anyways, we're going to create a new part studio. And like we did just now in the previous video or whatever it is I deselected, I hid some of the planes to leave one of the planes remaining, one of the planes right here, so that's less cluttered. And so one piece of advice that I'd really like to give is when you're imagining a part before it's even sort of made and you're imagining what it looks like, you always want to think of the easiest possible way you could CAD the model. Because models that look like this right over here, they look pretty complicated. And so why I'm saying like how is you're going to have to think of how you're going to CAD this, because there's basically, I'm assuming, an infinite amount of ways that you can CAD something. But you can select sort of multiple faces that you want to start from. For example, you can start from the bottom of this piece, on the base of this piece, and CAD it upwards, or you could take this side pattern. These two perspectives are two equally valid ways in which you could CAD it. Essentially, if you could sketch this, if you remember from the previous video, everything starts from a 2D plane. And so you're going to have to start a sketch from somewhere, from some plane. In this case, you can start from the side, for example, and CAD out this shape right here, this sort of like question mark looking shape on the 2D plane. And after you CAD that, you can extrude it and make those adjustments to make it look like this. On the other hand, you can also look at a model and interpret it like this from the top down and CAD this sort of shape. This shape that looks maybe like I don't know, a cutting board, this shape from the top. And you can CAD this and translate it to this model. Essentially, you're going to have to take a look at and decide which face, top, down, left, right, bottom, do you want to first make that sketch, to make that first sketch. And so to me, I think I can clearly see that one method is going to be a lot quicker than the other. And I think personally, I would go for this one right here, the one that looks like a question mark. And you'll see why. You sort of see it might be a little strange in explanation. It might not have been extremely clear. It might have been a little confusing. But I think once I start CADding it out, you'll realize what I'm talking about when I'm sort of saying you have to select the face that you want to start with. So instead of using the top plane, because this is facing upwards, I'm probably going to use the front plane. And that's completely arbitrary. You can rotate your parts and your assemblies, blah, blah, blah. And so taking a look at this first drawing, it looks like, I'm going to just CAD out this shape And it should be relatively easy. Using dimensions on both these different drawings, you can create this. Um, right over here on the bottom is a measure tool. This is actually really important, a really useful tool, especially when you have a 3D model right in front of you. All you have to do is click the measure tool and click a line or point. And so here I'm going to click this entity. It's going to immediately give me 150 millimeters at its length. But I can also do other things like distance between two things. For example, if I select these two lines, if I select not these 2 points, but these two lines, you'll see if you hover over them, you'll see these different distance measurements. So here, 85 millimeters is the parallel distance between these two. The X distance from, and you can see these very sort of like the maximum distance from one to another, one line to another, and things like that. And you can select the circle and you can see its diameter and sort of things like that. So this is a really useful tool. It's the measure tool. Anyways, so taking a look at this drawing right here, I'm going to try to recreate this shape right over here. And so if you remember from the previous sort of like section, we click the sketch button, we select the sketch plane, and essentially we can start drawing. We can start sketching it out. And so to keep everything centered, I always like to connect it to the origin. And the origin is really useful because it constrains everything. And so it keeps the position still. And sometimes you might run into issues where like you want to dimension something and the whole part moves away from the center. And so you want to make sure that some piece of your sketch is actually in contact. Let's use a term. Is coincident with the origin. So for example, just arbitrarily, I want this little point of the line, this horizontal line, to be the starting point, the line that starts in the origin. And you'll see why this makes a little more sense. It keeps everything constrained. So here, I'm just going to go with an arbitrary line right over here. And so I'm going to dimension it by pressing enter. When that pops up, it gives me a little dimension right here. This is a little different from, say, doing something like this. It's blue because it has nowhere to connect to. And so the position is no longer fixed of this blue line right here because I didn't connect it to the origin. Whereas right over here, I connected to the origin and the line is black, which means it's good. It's constrained. It's fixed. The position is fixed. So next, let's go back to our drawing and take a look at how long this first line, this one on the bottom, should be. And I forgot to put a little bit of dimension right here. So it should be pretty quick to add. You can actually, this might make a little more sense, but this line going all the way to the top, this might be a little strange. Right over here, all the way to here. And that's going to be 285, as you see right over here. So 285 is going to be that length of that line right here. I'm just going to copy it. So 285 is a little long. Sometimes you just got to zoom out. So use the cube to your advantage. Next, since that is 285, we're going to go up. Actually, we can probably go around. So we can CAD this one. So we know that this is actually 40 millimeters. More useful to add another dimension. So it's going to be 40 millimeters thick going up. And so what we do is we add another line. And here's what's fancy about Onshape sometimes, which I really like, is it automatically adds constraints for you. As you can see right here, right next to my cursor, there's a flat line. That, if you recognize it, is the horizontal. It is the horizontal constraint. And so automatically, just by clicking and dragging a line across the screen, it automatically assumes that it's going to be horizontal to me. And so it immediately adds that constraint. If you hover over any line, any point, you can see the constraints that are added to it. And you can see right here that it is a horizontal line. That's what I use right here. And that's what I can do with the next line. So I'm going to connect it to this point and go straight up. And as you can see that little vertical constraint, automatically added to it. So next, we're going to do that. I forgot to press enter, but it's okay because we can use the dimension tool. And right here is going to be 40 for the thickness. So we're just going to go back and forth between our drawing to just take a look at the different lengths. And so, of course, the dimensions it's missing right here. But we know that the thickness right here is going to be 40 of this part. So 285 minus 40, which is 245. So we know the line back is going to be 245. But what you can also do is put mathematical equations into your dimensions. For example, if I was really lazy and I didn't want to do the math, you could always do something like this: 285 minus 40. And immediately calculate it for you, and now it's 245. Perfect. We can move on. So next, we see that this length is 110. So we're going to add that again. Another line, 110. 110 is right there. Then across, so you can see it's going to be 150, then 85 down. I'm just going to try to minimize as many switches as possible from the screens. So this is going to be 150. Again, pressing enter to dimension. 150, 80 down, and then it's going to look like a little cross. So 40 across again. And you can feel free to follow along and CAD this with me. So 40 here, and just to be a little arbitrary, I assume that this is going to be 40 going up as well. And this is actually a pretty good point in using the equal constraint. So I'm going to use the equal. You can always press E for the equal. I'm going to equate this line to this, and boom, that turns into 40 immediately. So a really easy tool to use. Next, let's see, it's loading. It's going to be some dimension across, but here's the nice part. We can use sort of the other relationships around it, like somewhere like here, this starting line, to CAD and fill in the spaces, even though there are no explicit dimensions over here. Since everything else is already dimensioned, we can be sure that we can CAD the rest of this part just by using the dimensions and the relationships of the parts around it. What I mean by that is we extend this line up here. We can actually go across here and hover over this point and drag it across. And you can see that yellow arrow that is helping to dimension this. And that just means that it's on the same horizontal level as that line. And so if we click this, it will be 110. Okay, now, well, the length is 110 because, again, the constraints clash. The constraints clash if I add a dimension to this because it already assumed that the length was going to be 110 because we aligned it with this point. So we aligned it. It's right here. It has a, I'm not sure what constraint. It might be a horizontal, vertical constraint. I'm not too sure. But essentially, it's aligned with this. And so adding another dimension, the 110, would be completely redundant. And thus, it does not solve. So a little bit of an error by me right there. And so although we didn't label that as 110, we can dimension it to just check. It's 110. And so it's going to fade away in gray because it is not really irrelevant. It is not a relevant dimension. You cannot change that dimension without breaking your sketch. And so using this relationship between this line and this line, them being an equal horizontally, the equal horizontal position, we can, instead of using a number dimension, we can use that a dimension using relationships between just a simple spatial relationship between these two lines. Finally, we're just going to connect this. And as you can see, the whole shape fills in gray. And that actually means that the shape is completely enclosed, which means it can be extruded. So finishing the sketch, it's going to look like nothing yet, but we can use the extrusion. So let's see how thick we want to extrude this thing. So it looks like the most we have to extrude is 200. So what I'm going to do is there's a lot of ways you can CAD this, but I'm going to try to CAD it in a way that is subtractive more than additive, which means I'm going to CAD, you know what? I'll just show you. So I'm going to click right here for a sketch, extrude it for 200 millimeters, and it's going to extrude. And as you can see, it kind of looks like our shape now. It kind of looks like it, like a little bit, right? I mean, there's a lot of details missing, but it's that approximate shape. And so afterwards, what I mean by subtractive is if you look at the top down, there's these little cutouts, right? This little cutout that the shape actually has. And so what I can do is a subtract over here, is subtract the shapes, subtract that shape and sort of carve it out of the solid block right now. And so just going back to that concept of selecting a plane to first extrude, this is very, very tried and true right here, because I selected the front plane, the side of this object to extrude first, instead of going to top down, because I think this was the easiest way. So before you CAD apart, you start to CAD apart, think of the easiest way you can CAD it. So you want to think of the right plane or the right side of the part that you want to design first. So think of the easiest possible way you can design something, because I could have well CADed this big rectangle on top, but I think it would have been a little harder to do this amount of curve, like this sort of detail, this little frame almost on the bottom. It would have been a lot harder to include that detail if I just did a top-down sketch. If I started with a big block rectangle. Instead, I made this big, sort of slightly more complicated shape. So next, what you can actually do is with these parts is you can sketch and select. This is pretty important, but you can select different planes on your current object. It created a part right here because you just extruded it. It's now in the 3D world. You can select the sketch on any of these planes that you see on this part. And so essentially I just selected this plane. It's going to indicate that the sketch plane is the face of our first extrusion, right over here, first extrude. And so now I'm going to try to carve out that shape that is present in the first drawing. Essentially, I'm going to try to create this shape right over here. And so I am going to, let's CAD these. I'm going to sort of, this is sort of a slightly more complicated shape because it involves curves, but it's pretty simple. So this line is 75. So it's very useful to use construction lines. So by pressing Q, you're going to activate construction, which means the lines are not solid, which means they're just sort of guides for you. They're not actually going to create shapes. So right over here, I'm going to sort of map out that shape using construction lines just to understand and lay down that shape. So 75 here. Next, this is a nice touch, but we're going to need to use an angle dimension. So now we know that this has to be 135 according to the drawing, 135 degrees. And this horizontal length is 55, if I read that correctly from the drawing. Also maybe 55, so I was correct. Next, we have this line that sort of bridges, that connects the curve. So it looks like this. I'm going to do a construction line again, and that is 75 long right here. I think that was 75 at least. It was 70. Cool. All right, 70 right here. And here is where one of my favorite techniques come into hand, and it's called the mirror tool. And this is going to be really important, I think, generally in robotics, because there is a lot of symmetry with your parts. So essentially, the mirror tool is right up here. It'll ask for you to select the mirror line. It's pretty self-explanatory. After you select the mirror line, you want to select entities that will be mirrored across this line. In this case, I'm going to click and drag the box to include all of these different lines, and boom, it's going to show up on the other side. And there you have it. There's that little shape right there. And next, this is where the arc is going to come into handy. 3-point arc. I'm going to click at this point. It's going to ask for another point, and you want to drag it out. And so here's a really cool feature. This is one of the sort of advanced constraints that we have. It's called the tangent function, the tangent constraint. Essentially what it's saying is this, this curve is tangent to these lines. So when you go out, it's a perfectly smooth, what do you call it? Transition to this curve, and hence it's tangent. That's sort of a very dumbed down explanation of tangent, but here you have it. So here we have the curve dimension. Next, we are going to make solid lines out of this. So there's all been construction. Right over here, I'm going to drag this across, boom, boom. So I basically outlined the edge of here. Next, I'm actually going to unconstruct. Actually, no. First, I'm going to mirror this across the line so that it can be on the other side. And you can see here that if I actually put, the reason why it's a construction, if I put a construction line over here, it's kind of not really visible. But if you put a construction line right here, you can see that even though this shape is enclosed, it isn't shaded dark. Hence, it's not an actual sketch. It is a construction drawing. There's no function to that drawing. It's just a guide. But after we make these lines solid, so I'm going to select these lines and press the construction, which makes it back into a solid line, you will see that all of a sudden, it's kind of hard to see, but I believe these parts are now solid parts, if I'm not wrong. These are now solid, which means that when we try to extrude it, let's see if this works. I hope this really works. It's not going to work right now, but we can remove stuff. So we just went through new, which was just creating an arbitrary shape. But when you want to remove things, here's how you do it. You select the remove. And what I like to do is through all, which it doesn't even have a dimension. It just calculates, it goes through everything in its position. And thus, it carved out that little position, and using through all, you didn't even have to key in a dimension. It just went all the way through. So there we go. And it looks a lot more similar now. If you take a look at this, I'm going to use the cube. If you look at the dimensions, it looks more and more similar to this little piece right here. What I'm going to add really quickly, I'm going to go back to the sketch and actually add this right here, a circle. So I'm going to click on this little point that generated because of this curve, and it's going to be concentric. And I believe the diameter is 45 of this thing. The diameter is 45. Let us see. It is 50. So the diameter of this circle is 50, and it is concentric with this curve. And this curve had a point right here, and it's going to be concentric right there. And when we click this right here, this hole suddenly appears because we're removing it. We're removing it from this top piece. And the very last thing we have to do is to add or remove or to add holes to this very top part. What we're going to do is the same exact thing. We're going to select the face and press sketch. And now we're going to be sketching on this plane. You can see the plane, sketch plane right over there. And like we did with this part, we're going to remove the holes. And so what I like to do always is to add my construction lines. So you can see that if you hover over here, this is another useful thing, it will box the midpoint of your line. It boxes it and shows it to you. It boxes it. When I drag it down, it's always going to have, you can see that it's a dashed yellow line. The line is now dashed, indicating that it's also trying to automatically add a constraint for you. In this case, it is the vertical constraint here. And you're going to see that the line is black because it's perfectly constrained. The position is locked. We're going to do the same thing here. It finds the midpoint automatically as I hover over the line, and it also creates it's actually making a parallel relationship to make it completely horizontal. The line is now horizontal. We're going to press Q to make it a construction. There we go. It's a little construction line right there. And so this is really useful when you need something in the middle of a rectangle. It's a very useful way is use your construction lines. So here you can see that the center of the circle is 45 millimeters away from the edge. And so we can do that right here. So I'm going to take this point. Again, this is sort of like these are, I feel like I think the term is called inferred constraints. So by hovering over this, it's sort of, I guess it's not really doing anything right now, but it allows you to place something on this line. And the circle, when placed on this line, is now considered concentric. This point, as you hover over it, you can see that the icon is concentric. The point is concentric with this line. Of course, we can dimension this again. This is going to be 50 millimeters. And as we said, as it was shown in the drawing, this is 45 millimeters away from the edge. And so here it's another perfectly dimensioned. Like we learned just now, we're going to use the mirror tool and mirror this across the line. There we have it. Very simple CAD. And so this circle again was made. It was concentric, not concentric, coincident. Sorry, I might have been using the whole wrong term just now. It was coincident with this line. It is attached to this line. You can kind of see it. I'm going to get rid of this dimension really quickly. But since it's coincident, I can actually slide this up and down. Sometimes Onshape allows you to slide things up and down just to test around. But essentially, even though I'm dragging the cursor sideways, it's not allowing the circle to leave the line because it is concentric. So I'm just going to put the 45 back. I'm going to put the mirror back. And there we have it, our next sketch. And so I just want to slip this in there. You can also, in your extrude, add little extensions. You can extend and add features to your already existing part. In this case, maybe if we didn't decide to make a hole out of them, it would look like this. You would add two little prongs. It looks like a Lego piece. But if you press add, it will basically merge these two cylinders will merge with part one, and it will become an extension to part one. So we press enter here, it is part of part one. But if you choose to do it differently, it could cause some problems. For example, if I put new right here, these parts aren't actually attached to your piece. You can see it's indicated by the different colors. And down here, parts 2 and 3 are now independent parts, which means when you've gone to print them, you will run into some errors because they're considered separate parts instead of one singular part. So always, 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 if you're trying to extend a part, use the add function. If you're trying to add extensions to a part, use the add extrude function. In this case, though, we're going to try to remove it. Sometimes it'll do this because it doesn't sense that above this, you can see indicated by this arrow, that there is nothing to be removed above this piece. As you can see, there is nothing above for it to remove. And all you have to do is click this arrow and it flips downwards. And this arrow right here does the same thing. It flips the direction of your remove. And again, like we did just now, since we wanted to go all the way through and there's nothing else on the other way that we really worry about, we can do a through all command and it automatically makes it go through the whole part. And right over here, that is our cat. And just that was sort of my way of doing it from start to finish. And I think if we match it up, these should look very, very similar, if not the same exact thing. Let's see, let's go back and forth. And as you can see, this looks basically similar, just one is more zoomed out than the other. So that is my personal way of making this CAD. This was my way of taking this sort of image of a part and bringing it to real life and translating it into the 3D world. And so you may have a completely different sort of direction or idea of how to CAD this, because this is one of an infinite amount of ways you can CAD this piece you see right in front of you. So I recommend that from this drawing right here, which is now accurately dimensioned, you should be able to make this part right here on your own, using your own technique and your own sort of process, your own way of doing it. So as a good practice of constraints and everything, try doing this little practice problem right here. It's a big leap from the sort of first video of just extruding things, but this is a really good first step in the right direction. And honestly, I don't think there's a better way of learning CAD except, by doing it itself, sort of working on it, and actually creating the part that you see right in front of you. Tutorial hell never helps. So you want to be able to get your hands dirty and actually CAD a real part. So good luck. Try your best and CAD this part, and let me know if you need any help on this. So yeah, thank you.